Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Okay, thank you, Anna. Good morning, good afternoon, good evening. My name is Vishnu. On behalf of ITU and ZTE Corporation, we would like to welcome you to this session on In AI We Trust. So today we have an array of 3 expert speakers who will take us through the exciting topics around trust and security in AI ML in networks. ITU is United Nations Specialized Agency for ICT, Information Communication Technologies. This webinar is organized in partnership with ZTE Corporation. You can ask your questions via neural networks. Let's have a lively discussion. And after all the 3 talks are over, there is a 30 minutes networking session on AI for Good neural network. Our first speaker is Kewen Wang from ZTE. His current research interests include AI systems and AI security, such as federated learning, adversarial attacks, defense, and deep learning. He will talk on the topic of new safe, assisting safe production and application of AI. Let's welcome Kewen. Kewen, floor is yours. Good afternoon.
Okay, thank you. I will share the screen first. Okay, thank you. Hello, everyone. It's a great honor to be here to give a speech. Today, I will share some ZT's work on AI security. My topic is neurosafe, assisting safe production and the application of AI. I will explain from 3 aspects, the AI security background, and 2 projects under our neurosafe community, namely federated learning and security 2. First, I will briefly explain the background of the AI security. As we know, with the rapid development of AI, the AI has been widely used in all aspects of our lives, such as finance, medical care, and e-commerce, and so forth. While AI provides us with great convenience, its accompanying security risks are also gradually reviewed in these recent years. So what is AI security, and what are the risks it brings to us? Typically, there are multiple aspects about the security. I will explain from 4 aspects. First, the security, I will say safety or the vulnerability of the model or algorithm, which means the model or the algorithm is very easy to be attacked. And the second is the fairness. It's usually reference to the whether the algorithm or the model is biased when making the decisions, because if the decision is wrong, may cause many moral or ethical issues. And the third is explainable. The black box nature of the AI makes the decisions difficult to be adopted by human, because we don't know why the model makes a decision and the reason for the decision. So it's caused more concern about for people about the model. And the fourth, privacy, mainly reference the privacy of people, our company, especially the data, which may lead to the data silos problem. And all these problems mentioned before above has caused people's concern about AI security and their data security. Therefore, more and more research are devoted to the related fields. The number of the papers increased gradually every year, and at the same time, in order to regulate the development of AI, many countries have promulgated AI-related laws, such as the Personal Information Protection Law of China and the ethics guidelines for trustworthy AI of Europe. And also the organizations from all walks of life also issued a large number of standards, such as the overview of the trustworthiness in artificial intelligence, and the bias in AI systems and AI-aided decision making. Because the AI security determines the sustainable development of AI, so it's imperative. But first, we should know what are the causes of the security issues. In fact, the issues run through the entire life cycle of AI, and may face different challenges at different stages, including data processing, model training, and inferencing. Such as when collecting data, there are channel attacks and privacy leakage, and during the training and stage, there are maybe poisoning and backdoor attacks. Even in the deployment and inference stage, there also exist model extraction stakes attacks, black box adversarial attacks, and so forth. So we hope to find ways to resist these attacks to make our models, our algorithms more secure, and our data more private. And that is what we do. Let me introduce you our NeuroSafe community, which is an around end-to-end AI security open source community. It mainly includes 4 sub-projects, including federated learning, NeuroSafe security, and NeuroSafe fairness, and NeuroSafe explanation. The first, federated learning, aims to build an efficient, private, secure, and reliable federated learning platform. And the security 2 aims to provide a security service for AI development. And the last one, fairness and explanation projects may mainly focus on the trustworthy and the reliability of the model. And the first sub-projects is already open source, and the last 2 will open source later. Today, I will introduce the first 2 sub-projects. Okay, first, let me introduce the federated learning project. As we know, the federated learning is a machine learning technique that trains a model across multiple decentralized edge devices that hold local data without exchanging them to protect the data privacy. And our federated learning architecture adopts the design of microservice. Therefore, it's more flexible and extensible in development and deployment. We provide a standardized algorithm interface and have a good extensible design for new algorithms. We support multiple deployment modes to support different scenarios, and we provide plant management and the HA design of the core components and also the job level scheduling. Then I will go into more detail about all these features I talked about. First, our platform support 3 deployment modes for different scenarios or different needs. The first, the standalone mode is suitable for quick verification for the algorithm developers, and the cross-device model is suitable for a large number of devices, and we support device registration, management, and selection for the federated job. And finally, the cross-silo mode is more suitable for federated tasks among a small number of parties, such as between the several companies or several organizations, and any party can be the task initiator to communicate with other parties or to start a job. And on the right of the slides, here is an example of our machine learning training script, which migrate to the federated learning. As you can see, it needs 2 lines of code. The changes are very small, so it's very easy for you to migrate traditional training jobs to the our federated learning platform. And also, we are compatible with multiple popular frameworks such as TensorFlow or PyTorch. Next, in terms of the privacy protection, we currently support differential privacy and security multi-party computation, which is secret sharing based. And we also later we will support additive homomorphic encryption in the future. The users only need to refer this security algorithms in their configuration for their job. There's no need for them to have the background of the security knowledge. And you can see the result shown in the right of the slides. On the top, the weight-based differential privacy can control the accuracy within 1% under a certain noise budget. And the SSA on the bottom shows that the SSA can guarantee the accuracy and also supports the privacy aggregation even when the client drop out during the federated process. We support one mask and double mask model. The next, I'll introduce the extensibility aggregation of our aggregation and optimization library. One of the main challenge of the federated learning is heterogeneity of data. We provide federal average, scaffold, and federal proxy and other aggregation algorithms to deal with these scenarios. Especially, we hope to solve the convergence problem in the case with heterogeneous data, as shown in the left bottom in the finger. When the data in the client is heterogeneous, the scaffold and the Fed proxy can converge better than the Fed average. And also, we provide a flexible extension mechanism to support a new algorithm for the evolution. The federated process is not so complicated, mainly including broadcast and the report and the aggregate. So we provide 2 extension methods to extend the federated process, which is callbacks and the standardized algorithm interface. The first one, you can register a callback function, then you can implement your custom calculations in the federated process. And the second, you can inherit the corresponding base class and compile it into our framework. The first one is simpler, and the second one is more flexible. So you can choose according your needs. Okay, let's see some applications of our federated learning platform. First, we apply our federated learning to the network intelligence to break the boundaries between network elements, reduce a large amount of data transmission, also ensure the data privacy. And finally, we achieve the same accuracy as the centralized solutions on the network log analysis problem. And the next other applications of federated learning in IoT scenarios. The first one is to solve the intelligent problem of some edge devices. The edge device join the federated learning through nearby edge gateways, which utilize edge side data privately and enhance the data edge intelligence capabilities. The other one is lifelong learning scenario, which hope to solve the problem of knowledge forgetting. We have properly modified the federated process and use the lifelong learning algorithms to solve the scenario where the data distribution may gradually migrate over time, and under the premise of protecting the data privacy. Okay, that's our federated learning project. And next, I will introduce the NeuroSafe security project. It's a security tool for AI development. Our security tool mainly provides capabilities such as adversarial attacks and defense, model safe defense, model robust evaluation and enhancement, poisoning detection, and robust algorithm against it. We have a powerful security algorithm library, and we provide unified service entry to show the underlying implementation. So it's very user-friendly and easy to use. All the algorithms are compatible with multiple machine learning frameworks such as TensorFlow and PyTorch, and also support extension. Also, we introduce some algorithms in popular fields such as face recognition, auto driving. First, let me introduce the attacks algorithms. We have implemented a large number of attack algorithms, including black box and white box attacks, which has more than 30 algorithms. And we classify the algorithms, extract and implement the commonalities of the similar algorithms to avoid repetitive work, and let algorithm developers focus on the core of their algorithm, so they can develop faster, perhaps with only a few lines of the code. As you can see, the PGD attack based on our gradient-based attack, they only need to write 4 lines of code of the query code to implement this attack. So it's very easy to implement the new algorithm. And here is some adversarial examples generated by our neurosafe security tool. On some common data size, there are target and non-target attacks. As you can see, different types of algorithm generate different perturbations. Some are very hard to detect by our human. It does not affect human classification, but it will lead to the classification error with high confidence by the model. And with all the attacks we talk above, we have realized the robustness detection of the model. That is to say, we conduct a comprehensive attack on the model and then evaluate the data indicators to generate a model robustness report. The report will detail under which attacks the model is vulnerable, draw the attack curve, and give the corresponding reinforcement suggestions. We have a lot of metrics to evaluate the model, and also the auto learning and auto parameter learning to learn the best adversarial examples. Okay, this is how we use it. We only need to use the provided command to detect the model, set the required parameters, test examples, and other configuration, and then you can generate the robustness report of the model with only one command. The report is shown in the right of the slides. This is just part of the report. Okay. So in order to deal with above mentioned adversarial attacks, we provide 3 types of defense measures, namely model reinforcement, adversarial example detection, and adversarial example recovery. We provide several ways to use these capabilities. Next, I will introduce these 3 defense methods respectively. First is the model reinforcement. We provide a large number of defense methods to reinforce the model, such as adversarial training, image transformation, gradient masking, and defense distillation. As you can see, after reinforcing the model, the attack success rate is greatly reduced in the face of adversarial attacks, which dropped from 95% to 25%. And second, we provide adversarial example detection, whose main purpose is to distinguish adversarial examples from benign examples by a detector. We have four ways to train this detector. The detector, next thing, the detector is attached before the inference network and the deny service to the identified adversarial examples. After the detector is well trained, the detector success rate of the detector can reach to 90%. And finally, we provide the recovery of service of the adversarial example using the algorithms to denoise or reconstruct the adversarial examples to the good examples. Similarly, we attach the recovery network before the inference service to restore the adversarial examples to the good examples, and then perform inference services on the recovered examples. As you can see on the bottom of the slides, the recovery examples is almost the same as the original example. Okay, that's all my sharing today. Thank you very much.
Thank you very much, Kewen. Do we have questions? I don't see questions. Let me ask a few questions. So thank you very much. It's a really interesting talk. Can I ask you, how does this reinforcement techniques, model reinforcement techniques, adversarial detection techniques, does it affect the performance of the model? I mean, accuracy and other functional metrics of the model. So accuracy, precision, and so on, which we normally track. So when you reinforce the model, does it affect the accuracy at all, or what is your experience and studies, please?
Okay. Pardon. What's the question? Network is.
The model reinforcement techniques that you talked about. Maybe the model reinforcement, does it affect the accuracy of the model? Does it reduce the accuracy or increase the accuracy of the model?
Accuracy and okay. I don't think. I think the accuracy of our model is can be the same during using our security tools. Almost there, we won't reduce the performance of the model. It's in some scenarios, maybe such as differential privacy, it may be reduce a little accuracy of the model, but it's you can change your parameter to increase this accuracy according your needs, such as you can minimize the noise budget. I think.
Thank you so much. Yeah, that makes sense. Another question, you mostly talked about horizontal federated. Will you support vertical federated in the future?
Yes. The current the current research of our open source part is mainly oriented to the horizontal federated scenario, and the vertical federated is developing internally, and this will release next year in the next year versions, and also the transfer federated also will be introduced later. And thank you for your attention. If you can, I will give the GitHub address of our open source community to the comments. You can check later.
Thank you very much. Yeah, thank you, Kewen, for that very interesting talk. And if you have more questions, they will be coming in the neural network. Please ask your questions in the neural network for the audience who have more questions for Kewen. Next, we move to the next speaker, who will talk about towards interpretable deep learning. That's a very interesting topic. Shuhong Li is here. Shuhong Li is a researcher at Big Data Laboratory of Baidu Research. He received his bachelor degree and master's degree from Beihang University, China, and his PhD from University of Technology Compiègne in France in 2019. He's interested in explainable AI and transfer learning, self-supervised learning, multimodal learning, in vision, NLP, different type of applications. He's widely published. There's a long list here, as well as he has regularly served among program committees in top machine learning conference. So we would welcome Shuhong at this moment. Thank you for taking the time. The floor is yours, Shuhong, please.
Okay, thanks for the introduction. And I'm honored to be here to give the presentation about our recent work on the interpretable deep learning. This is the outline of my presentation. It divides down into two parts. The first one is the introduction to the interpretable deep learning, including a quick background recall on the artificial intelligence, deep learning, etc. And then we have done the literature review on the explainable artificial intelligence. And we also propose a taxonomy to categorize the existing interpretation algorithms. And we also present our open source toolkit for explainable artificial intelligence named InterpretDL. And the second part of my presentation is about the research work on explanations and interpretations. Here we have 4 works to present. I'm not sure I have enough time to present them all, so maybe we will focus on the last 3. The interpretation on training data, and this is a novel direction for the explanations. We would like to analyze the training sets to see how the training samples contribute to the trained model, to explain it. And there is an empirical study about the consensus of cross-model explanations. There are several interesting observations from this work. And the last one is learning from explanations. Based on all these explanation results, how can we use the explanations to improve the deep models? So let's start. First is a background. As we know, deep learning models are now very good at solving many artificial intelligence tasks, such as image recognition, natural language processing, speech recognition, reinforcement learning, etc. But why deep learning is so effective? Compared to traditional machine learning, deep learning does not need to design expert features. Instead, deep learning models take the raw data as input, learn features by themselves, and output the predictions directly. This end-to-end fashion is proven to be quite effective and works very well, especially when there are a lot of labeled data available. However, the deep models are more like a black box with unknown intelligence inside, and we have no ideas about how it works. This makes it difficult to apply the black box models to some special cases, especially when concerning personal and property safety, like autonomous driving, financial decisions, security measures, etc. So we need expandable artificial intelligence to understand how this black box works. Here we summarize 4 reasons that why we need the interpretability. Besides model understanding, model debug is another important reason. We need to investigate why the model does not work well to fix the bug and improve the model performance. The third is a safety and social issue. We have to be careful about the decisions the model make when concerning personal and property safety. Bad decision in these cases will cause severe damages. Social issue is another reason. Sometimes the deep models will biasly locate some features or use some personal information to make decisions. Without an explanation, we can't easily detect this bad behavior of deep model, and that would cause much trouble if this model is widely used. Last is the human curiosity of exploring the unknown scientific fields. Deep models have already been used in many physical simulation experiments, for example, and in some cases, deep models work very well. However, without explanations, what we obtained is maybe just a powerful computation machine of black boxes. We still have no ideas about the real scientific theories behind. We need to reach the truth by understanding how the model works and how it produces the results. That is also the idea of AI for science. So explainable AI aims to improve the interpretability of black boxes. That is also to transform the black box to a transparent one, where we can understand the theory inside and know how it makes decisions. Based on these backgrounds, we have done a comprehensive literature review and proposed a taxonomy to categorize the existing interpretation algorithms. The first one is self-explainable models. They are usually designed with Bayes, causal inference, logicism, or other designs. This direction focuses on directly building a self-explainable model instead of explaining the existing models. As contrary, the second and the third one do not change the existing training strategy or the model structure. They are easier to combine with the existing works or models. So the second category is a novel one that gives the interpretations on data, especially on training data. This helps to understand how each training sample contributes to the trained model. For example, on the figure on the right, whether there are mislabeled sample in the training set, whether these samples are difficult for the model to learn or easy to learn. There are several interesting works that can explain that can analyze the training samples from this field. For example, influence functions, forgetting events, and training dynamics. We will also introduce one work based on training dynamics in the second part of this presentation. The third category is the post hoc interpretations. Most of research works focus on this direction. They mainly focus on explaining the models that are already trained. Post hoc interpretations are also divided into two classes. Local ones means the model explains the models, the methods explain the model's behaviors for one specific sample. Global ones mean to explain the whole model directly. Local ones can be further divided into input-output mapping and intermediate features. Input-output mapping can further be divided into non-differentiable and differentiable according to the requirements of gradients. Lime and sharp do not need gradients to compute the explanation results, while smooth grade and intergrade do need gradients. Algorithms on intermediate features focus on analyzing the contributions of intermediate neurons, the intermediate channels of the neural networks. Yes, that's pretty much the post-hoc interpretations. With the help of interpretation algorithms, we can measure the model interpretability to say how interpretable is a model. However, the first step in this pipeline is to guarantee the interpretation algorithm is trustworthy or faithful. We can use trustworthiness evaluation to validate the trustworthiness of interpretation algorithms. Then, using the trustworthy interpretation algorithms, we can calculate the interpretations of deep models. Then we compare the interpretation results with the human understandings to measure the model interpretability, because usually interpretability is defined as the alignment with human understanding. Human experts can annotate the semantic parts of the data samples, and we can directly measure the similarity between interpretation results and the human annotations to measure the model interpretability. With this slide, we can maybe it's easier to know the difference between trustworthiness and interpretability. We can say that the explanation results reveal what a model may have learned, and this should be measured. This should be validated by the trustworthiness evaluations to guarantee the algorithm is loyal to the model. The interpretability is to measure the alignment between the interpretation results and the human annotations. We can say that human annotations cover all these birds, while the interpretation results focus maybe on the head of the birds, not the whole part of the bird. All of this may sound a little complex, a little complicated, but don't worry. All of this, including the evaluations, taxonomy, and the mentioned algorithms, are all implemented in our open source toolkit InterpretDL. We have done the comprehensive literature review and proposed the taxonomy, and we have various explanation algorithms. We also follow the plug and play and the module designs to implement our toolkit. We also have the visualization methods for directly showing the black boxes to understand the black box. In short, welcome to use our toolkit InterpretDL. It's simple to start and it's ready to use. It's really easy to use. Okay, the second part, I will introduce several of our recent research work. Maybe I will skip the first one, though it's also a very interesting work. If I have enough time, I will introduce this GLAM work to the end. Okay, let's say this first. It's a method based on training dynamics to analyze the training set. It's specifically to identify mislabeled samples in the training set. This slide shows that there are many samples that are incorrectly annotated by humans. Though this work, or we take the figure from this work, they focus on the noisy samples in the test set. We also found many noisy samples in the training set as well. Noisy labels would harm the generalization performance of trained models. If we can identify the mislabeled samples, even simply remove them will improve the model performance. Recently, many works use training dynamics to identify the mislabeled samples. Training dynamics are defined as the output of a model F. For example, the output of the model can be the probabilities. So the training dynamics L is the output of the model F for each training sample xi at each training epoch t. So previous works use, for example, GMM or rules or user-defined formulas to separate noisy samples from clean ones. These works already show very promising results on identifying mislabeled samples. However, in our work, we ask why not let a deep model learn features from the training dynamics by itself. This may be this is a supervised training task for a deep model, which the deep model is very good at. Unfortunately, for the supervised learning, we need the information whether the sample is mislabeled or correctly labeled. But this information is not available from original data sets. But good news is we can manually change a small part of labels so that we know so that we know which samples are mislabeled, which samples are clean. We can use this supervision to train a noisy detector to help us to directly classify the mislabeled samples from the clean ones. This strategy works very well, not only for the sensitively noised datasets, but also for the real-world noisy datasets too. Based on this framework, we have done 3 different evaluations. The first one is directly identifying mislabeled samples on the sensitive to noise datasets, where we can see our methods, the blue curves outperforms previous SOTA significantly. The second evaluation is to remove the noises and retrain the model on the rest of the training samples. This kind of evaluation is done on both sensitively noised datasets and real-world datasets. On both of them, our approach is better than the other baselines. The third evaluation is to combine our method with learning with noisy label algorithms, because our method is from the data part, and this learning method is from the algorithms part. So we validate, we verify that they can be used together to further improve the performance. So in summary, we propose a learning-based solution using training dynamics to identify mislabeled samples. And we have done 3 evaluations to validate the effectiveness of our approach. Okay, let's see another work. this is more than an empirical study. Our motivation is that we observed that though many different models can give different explanations, but some common features are shared across these models. We would like to ask what are the common features are, and whether the model that aligns with the common features has better performance. These two figures are two examples using lime and smooth grid to calculate the explanations. And the last column is a cross-model consensus of explanations. That is the average results across models. Specifically, this is a framework we use. We propose the consensus and the consensus score. We form a committee with over 100 models as committee members. Then we let every committee member to vote. For each image, we take the explanations as their vote. And the voting result is a final consensus. Here we simply use the average results as a final vote. Then we compute the similarity between each vote and the consensus to obtain the consensus score for each committee member, that is for each model. With the consensus and the consensus score, we have several interesting observations, I think, as introduced below. The first one, as you may already notice, that the cross-model consensus of explanations is aligned with image semantic segmentation. As shown in the images of the bird, the consensus focuses on this bird. Besides the visualizations, we have also a statistic result because ImageNet has no segmentation annotations. Here we use the models fine-tuned on the CUB dataset. This is a dataset of birds. It contains both image-wise labels and pixel-wise labels for image segmentation. We only use image labels to fine-tune the models, and the pixel-wise labels are used to measure the alignment between the consensus and the segmentation. This figure, let's look at the x-axis here. That is a mean average precision to the ground truth of image segmentation. We can say that the red star, the consensus, gets a much higher MAP score than any single model. For image classification models, the explanation results usually get mixed with the objects. So many weakly supervised learning methods for object detection or segmentation are based on explanation results too. We believe our findings build a clear bridge between image classification and image segmentation. Moreover, on other tasks and other domains, we believe the consensus also exists, but in a different type of representation. Let's move to the second observation. This answers the second question, whether the model that aligns with common features has better performance. The answer is yes in most cases. The similarity to the consensus is in fact the consensus score. Model performance is precision, the accuracy of the validation set. We average the results across the ImageNet validation set, and we find a strong positive correlation between these two metrics. Based on these observations, we believe that the consensus is the important feature on the data. If one model uses these features to make decisions, it would be very probable to be correct. The third observation is that the consensus score is also correlated to the interpretability. Interpretability is defined as the alignment between the human understanding and the explanation results. For image classification tasks, the human understanding is usually the image segmentation. So segmentation ground truth here is considered as the human understandings. So we compare the consensus score with the alignment to the segmentation ground truth. This is also done on CUB birds because ImageNet has no segmentation ground truth. And here are the results and observations. For other tasks on other domains, things may change because image classification and image segmentation has some special links. This may not exist in other domains, but we believe there will be similar observations and maybe more interesting. Then we have done the analysis to show how many members do we need to form a reliable committee. Because in our experiments, we use over 100 models to form the committee. It takes too much computations. So here we investigate the convergence of consensus with increasing the committee size. For each committee size, for example, 10 members, we randomly pick up 10 models from the complete committee with replacement for 20 times. Then we compute the MAP score and plot the boxes with increasing the committee size from 3 to 30. The red dashed line is the MAP scores using 85 models. This is done on CUB dataset. We can see that when using 15 models or more, the MAP score is close to the result of 85 models. At last, we would like to know what the consensus really is. We use a classic marginal probability formula to explain. We use PF to denote feature importance or the importance distribution over the features. PF is from the data view in our opinion. For every well-fit model, the feature importance PF given M can be revealed by explanation algorithms like Lime or smooth grid and many others. So a sum or an integration over all models would converge to the true feature importance from the data view. That is consensus does. So we informally say that the consensus is explanation of data instead of individual models. For image classification tasks, consensus is very easy to notice because they are the visual results. The easiest way and probably the only way to recognize the object is from the object itself. That corresponds to the image segmentation. While in other domains, this may be more difficult, but we believe that the important features from the data view can be found by the proposed consensus and can be helpful to guide the learning process. Okay, the last work is based on consensus and its alignment between the consensus and the image segmentation. We use these observations to improve image segmentation models. Image segmentation models usually take the classification backbone to initialize the weights, while leaving the segmentation module with random weights. When segmentation module contains lots of parameters and when the training set is not large enough, this usually leads to a bad generalization performance on the test set. To address this issue, we propose a pre-training strategy using pseudo-semantic segmentation labels to pre-train the whole segmentation model en masse. These pseudo labels are generated by cross-model consensus. Specifically, we construct the PSSL pseudo-semantic segmentation labels dataset based on the ImageNet training set that contains 1.2 million pseudo labels corresponding to the whole training set of ImageNet. Then we use a constructed dataset to pre-train the segmentation model en masse. With only 5 epochs on PSSL, we can obtain a much better pre-trained model than ImageNet's classification model. We do the evaluations on 5 datasets and across 3 different model structures. All of them show the improvements. And for convenience, we also published this dataset and the pre-trained models. You can get them from PedalSeg. Okay, that's pretty much all the presentation. I give a simple recall. The first part is about the introduction, and we also here we present our open source toolkit for XAI, named InterpretDL, and welcome to use it. And the second part is about 3 research works on explanations. For example, on the training sets or the empirical study about the cross-model consensus of explanations. And the last one is how to use the explanations to improve the models. Okay, that's pretty much the end of the presentation. Thanks for your attention.
Thank you so much, Shuhong. This is a very interesting talk, very comprehensive talk with a lot of reference papers. Thank you so much. There is a question in the chat. Could you talk a little bit of applying such techniques and tools to other types of data sets other than image classification? I mean, I think you mentioned some of the problems in your talk. Could you talk a little bit more about how to apply this to other types of problems and data sets? Yeah.
The question is the consensus for other domains. Is that correct?
Yeah.
Okay. We think we can use consensus on the natural language processing. For example, movie review. We can this task is about classifying whether the review is positive or negative, and the consensus. If we use the explanation on these sentences, these reviews, we can extract the positive words or negative words. If we use several models, we can use a consensus to locate precisely the negative words and positive words. I think this can directly be used in this task. But yes, as I already said, the limitation is the main limitation. I think is most explanation algorithm is focused on the classification tasks. If for the other tasks, regression is okay too. For example, object detection, that would be much difficult, I think.
Okay, super interesting. Yeah, it's really interesting. Yeah, I would like to take a look, and I encourage the audience also to take a look at the PaddleSec link that Shuhong told. Also, please hang around in the neural network for more questions at the end.
Okay.
So thank you, Shuhong, again for that really interesting talk. Yeah. We move to the next part, which is privacy preserving computation with security and compliance. Dr. Jing Fang is here. She is a research expert at Shanghai Fudata Technology. She's PhD from Nanyang Technological University in Singapore in many research projects in this area, including blockchain, many different fields, finance, medical care, energy, etc. She's deep into anti-fraud projects and also led research on electric power, many research reports and white papers, etc., including telecom operators. So there is, she has worked on local standards on public data and intelligent connected data. So that's a super interesting talk waiting for us. Dr. Jing Fang, welcome, and the floor is yours. Thank you for coming and taking the time. Good afternoon.
Good afternoon. Thanks, Vishnu, and thanks for the invitation from ITU. Hello, everyone. My name is Fang Jing, and I'm from Shanghai Fudata Technology. My topic today is how to achieve privacy-preserving computation with security and compliance. My speech consists of 4 parts. The first part is about the background of trusted privacy-preserving computation, which is PPC in short, that requires security and compliance. And the second part is our solutions for anonymous federated learning, which is AnonymFL in short. And we also have an inspection tool for PPC security. And the third part is about some relevant application scenarios in cases of AnonymFL. The last part is our thoughts on the construction of data element market and the development of the industry. So in the first part, we will talk about some background information. So in recent years, China's policies related to data element market have been gradually introduced. The relevant opinion on the data basic system issued in June this year, pointing out that the property rights operation mechanism should be established for the ownership of data resources, the right to use data processing, and the right to operate data products separately. At the same time, the linkage of law on network security, data security, and personal information security has put forward to strict requirements for data security and privacy protection. Also, in January this year, the PBOC, which is the People's Bank of China, released the Financial Technology Development Plan from 2022 to 2025. Which pointed out that the applications of secure multi-party computation, MPC in short, federated learning, which is FL in short, differential privacy, consortium blockchain, and other technologies should explore the establishment of a cross-entity data security sharing PPC platform. So in this context, PPC technology has become the core means to promote the secure circulation of data elements. So PPC allows data processing, use, and circulation without transferring control and makes it available and visible. Different technical routes of PPC can derive different product functions to meet the diversified needs of data circulation, such as query, fusion, statistics, modeling, and can also combine hardware technology to achieve a secure isolation environment that cannot access sensitive data through chips. So MPC FL, private information retrieval, which is PIR in short, and private set intersection, that is PSI in short, and trusted execution environment, which is T, can give consideration to data privacy protection and data value mining. Under the premise that the data is available but invisible, they can achieve no trace of query, no ID leakage, no data exposure, and algorithms running everywhere. So it can solve the problem of data silos and to some extent that meet the legal compliance requirements. As a technical solution for the secure circulation of data elements, PBC bears high expectations. Firstly, PBC meets statutory data security requirements from the Network Security Law, the Data Security Law, and the Personal Information Protection Law, which is PIPO in short. Secondly, PBC helps to implement the principle of minimum necessity from PIPO and to prevent data abuse. Thirdly, the technical solution of PBC is helpful to alleviate the compliance pressure of authorization and consent of participants from PIPO in data circulation and utilization. Although PBC can reduce compliance pressure to a certain extent, there are still some compliance risks in the actual application process. First of all, PBC participants jointly process personal data, which makes it difficult to obtain individual authorization and consent alone. In accordance with PIPO, the processing of personal information should be authorized by individuals. Secondly, PBC uses encrypted methods to protect the original data, but the fragmented data using homomorphic encryption or secret sharing can be decrypted or restored. So it cannot meet the anonymity requirements of personal information processing that cannot identify specific natural persons and cannot be restored. Thirdly, the personal identification information, labels, and features of PBC are not out of the domain. There's only intermediate data, encrypted data, and fragmented data interact, and the original data cannot be inversely deduced. However, in the process of sample set intersection, all participants have obtained the IDs in the intersection, so there is still a compliance risk. Meanwhile, there are 4 security black boxes of PBC that may cause difficulties in establishing trust between manufacturers and clients. The first one is algorithm black box, which is lack of transparency to users and rigorous security review. Because PBC manufacturers sometimes modify algorithm protocols to improve performance. The second one is code black box, which is impossible to check if the algorithm is actually consistent with the original design because malicious people can modify the codes. The third one is data black box, which is difficult to verify if there is data leakage because of the opaque intermediate data. The first one is application black box, which is a higher cost of understanding PBC because combination of algorithm is uncertain for security. So in view of the above-mentioned compliance problems in PBC, we have developed and innovated a set of solutions that can protect the intersected user IDs from leakage and meet the compliance requirements of PIPO, which is called NNMFL in short. So the application of federated learning in China focuses on the big data operation scenarios across institutions and organizations, especially in the financial industry. It can integrate different data between different institutions without domain and algorithm restrictions, and has the advantage of lossless model quality, privacy protection, and data security. Under the encryption protection, the intermediate computation results of FL, such as gradients and step sizes, are constantly exchanged. So the federated learning itself also includes 2 different technical rules. The first one is horizontal federated learning, which is discussed by our previous speaker. That is, different institutions overlap more in user characteristics and less in user samples. So we can expand the sample size and joint modeling and improve the model prediction effect through cross-agency sample expansion, such as interbank joint marketing. The second one is vertical federated learning. That is, different institutions overlap more in user samples and less in user characteristics. So we can expand the feature scale of joint modeling and improve the model prediction effect through cross-industry feature expansion, such as joint risk control between banks and operators. So at present, the security intersection technology commonly used in the industry, including different routes based on RSA and oblivious transfer. They have a common feature that only samples outside the intersection are protected from exposure, and user IDs within the intersection must be synchronized with all participants, because subsequent federated training cannot be conducted without synchronization. Is it fully compliant to share ID after hash encryption? The answer is no, because ID hash encryption can still uniquely identify a specific natural person. Therefore, the legal department of many institutions will request to suspend external data service cooperation through PPC. So in order to overcome this technical bottleneck and meet the compliance requirements, under the guidance Professor Lai Xuejia, who is a senior member of the International Cryptographic Society, our team of scientists developed AnonymFL. It includes 3 parts. The first part, it's about anonymous alignment, which realizes multi-party sample alignment without disclosing all sensitive information, including intersection. The second part is anonymous processing. It can ensure the personal information that cannot be identified to specific natural persons and cannot be recovered after processing. The third part is the anonymous learning algorithm, which can complete the federated learning modeling and federated evaluation without disclosing the intersected IDs. So different from traditional federated learning, AnonymFL no longer uses secure intersection to output the sample IDs, but let samples outside of the intersection set enter the training process. Participants don't know which samples have participated in the joint modeling, so as to avoid exposing their user IDs. For the aligned samples, we also designed the federated learning algorithm. Under the anonymous condition, joint modeling and iterative training can be conducted and until model convergence. The anonymous sample set will no longer belong to personal information and no need to obtain the user's authorization and consent. It can perform various compliant computing, modeling, and processing, and will become a kind of data element that retains high value and security compliance. So this figure intuitively shows the execution link of AnonymFL. When multiple participants from P1 to Pn conducts AnonymFL in anonymous alignments, the white part indicates the secret interaction between the two sides, while the red part indicates that the ID does not intersect. Anonymization refers to the operations related to noise reduction, weight of evidence, and other feature pre-processing of encrypted data. The anonymous learning part includes batch data acquisition, model training, test set evaluation, and parameter updates. And anonymous data can be used for anonymous training and evaluation, which can realize algorithms such as logical regression and neural network. The overall idea of our current AnonymFL is based on the MPC secret sharing method. Taking the secret sharing addition as an example, the participants ABC had their own data and split them into random and secret partitions by secret sharing method. The secret partitions remain on their own side, while the random partitions are exchanged with other participants. Each participant performed the addition operation of its own secret partition and random partition of other participants locally, and then obtain the aggregation results. In the process of an intersection, we adopted the computation mode of MPC comparison, supplemented by some optimization methods. Different from the common security intersection, for the anonymous sample alignments, the participants cannot know the sample ID of each row of the other party and even their own sample ID. The number of intersections will not be exposed, which can avoid differential privacy attacks. By fragmenting the user ID and secretly sharing it to each participant, all parties cannot independently obtain the complete information of the user ID, but only obtain the fragment value of whether the element exists in the set. So 0 represents non-intersection and 1 represents intersection. When the initiator uses data in each iteration, it needs to interact with the partner to determine which line of his data is really meaningful. That is to distinguish between 0 and 1. After anonymous alignments, anonymization under encrypted conditions is performed to obtain data that is no longer personal information. So the original data is on the left side, and the transformed result is obtained through an anonymous processing. Even if it is disclosed, the original record information corresponding to the current record cannot be inferred. At present, our method is mainly to increase the random value noise and obtain the transform features by anonymous WOE, so that the transform ID and features cannot be inversely deduced. The whole process of anonymous FL is basically the same as that of classical vertical federated learning. Participants load their own sample fragments and initialize weight fragments, divide the set into fragmented training sets and test sets, use feature fragments and weight parameter fragments to compute activation function and loss value function value fragments. Then compute local gradients based on encrypted operator, judge gradient size, and update local weight coefficients, and iterate continuously until the model converges. The samples not in the intersection also participate in the training, but its value is a shared and encrypted state 0, so they will not have any impact on the results. The computation and communication amount of anonym FL will increase, so we optimize the space storage, making the overall training time still within an acceptable range, achieving the availability of performance while maintaining the accuracy. Then I will introduce our security inspection tool named PackGuard. In order to open the security black box or PPC we mentioned above to achieve trustworthy security, the inspection tool needs to verify if the PPC product can ensure protocol, cryptography, communication, storage, system security, and system stability, authentication and authorization, and log certification as well. The inspection tool will do beforehand prevention, process supervision, and post-auditing. Our PackGuard can do intelligent parsing of algorithm messages and logs, real-time check of algorithm protocol consistency, real-time monitoring of signaling execution consistency, intermediate data specification analysis and detection, and multi-platform compatible adaptation. So it can also provide algorithm protocol sampling and evaluation, create auto-detect task, real-time sampling, analysis and detection, as well as reporting risk and offline auditing. The captured algorithm messages are aggregated according to the aggregation ID, and the consistency is checked and judged by combining the algorithm protocol and the running log. Lastly, our inspection tool has visual monitoring screen and analysis perspective, including node network, operation log, monitoring, alarm gateway communication, and algorithm interaction process. So after understanding the technical ideas of AnonymFL, we can take a look at its application scenarios, especially in financial industry. The first one is the anti-fraud scenario of the joint risk control, where banks need to identify the risk of zombie card fraud, prevent abnormal transactions, and recover customers' property losses. However, it is difficult to find abnormal fraud only by relying on its own data, which leads to high levels of fraud cases and can only freeze and break cards. So the bank will contain the sample data of normal and abnormal transactions of its own account and conduct joint modeling with the operators through AnonymFL to build an anti-fraud identification model. When there is a new account opening for the application that cannot be judged whether it is a normal transaction by using its own data, the bank calls the anti-fraud identification model through PIR and identifies the fraud risk according to the score and model analysis. After the federated fraud identification model was launched, the bank avoided most of the fraud risks. Compared with using only its own data, the fraud risk decreased by 30%. And at the same time, it also protects the customer intersection between the bank and the operator so that it can meet the compliance requirements of both parties. The second one, it is the scenario of credit card leads generation for joint marketing. The specific business requirements is that the bank hopes to find high-quality credit card users, cooperate with operators and other external institutions to carry out marketing activities. The bank hopes to use the user-side insight model to generate higher conversion rate and approval rate of credit cards. The corresponding solution is to build a credit card risk response model using the user's card opening data, terminal data, consumption behavior, browsing behavior, without disclosing the intersection data through AnonymFL. The application of AnonymFL to credit card leads generation has significantly improved the overall marketing effects such as ROI, purchase rate, click-through rate, and other indicators compared with expert rules and general rules. So 25,000 credit cards have been issued within 1 month, reducing the marketing cost. The card checking rate reached 37.7%, which is 29.5% higher than that of traditional experts model. So the above are some innovative ideas about our PPC security and compliance scheme, and also a brief introduction of our company. Our company called Fudata Technology. It focuses on product and solution on PPC technologies. We're the leader of the first national standard project of PPC interconnection, participating almost all PPC standards home and abroad. We are the undertaking unit of the MPC project of the Ministry of Science and Technology, and the only PPC manufacturer invested by China Internet Investment Fund. Our clients covered in industries from telecom, finance, power, automobile, government, and medicals. And our R&D personnel also account for 70% of the entire staff. Our product is called Avatar. It's an operator-level PPC platform that can support computation of billions samples, including MPC, FL, PSI, PIR, and consortium blockchain as well. So reviewing the overall development of PPC from the initial unified terminology and theoretical laboratory exploration to the engineering, security, and performance improvements of the production system, to the establishment of an interconnected ecosystem and the current data element market construction. The standards of PPC and the industry have made great progress. During this process, we participated in the preparation of the main standards, passed the relevant evaluation of the function, performance, and security of our products. We also took the lead in carrying out the theoretical research and practical application of interconnected activity. We have made corresponding contributions to the compliance and healthy development of data element market construction. And we also hope to explore the key technologies of data circulation with our peers and clients so as to convoy the development and growth of the digital economy with corporate compliance. So that's all for my presentation today, and thanks for listening.
Thank you very much. That's absolutely impressive talk, Fang Jing. Thank you so much. And I have a question on anonymization when you use these techniques, especially with federated learning. Sometimes the data is really complicated. I mean, from an operator perspective, it is a little difficult for us to figure out which part of the data needs to be anonymized. So especially when you are using federated learning, how do we decide which part of the data needs to be anonymized? Is it the job of the federated learning client, or do we need to have domain expertise to decide which data has to be anonymized? Could you give your thoughts, please?
Okay, thanks. So your first question is about the data, right? Right now, the anonymization is only for the structured data, and we haven't touched the unstructured parts because most of the application for our industry is more about logistic regression for the risk control. So it's more about financial data and operators data. All of them, maybe we can transfer it into structured data. But for the maybe CV, like the unstructured data, like face recognition, we have other methods, which is not anonymized. So it will not protect the intersected ID, but we will use the secret sharing method to separate the face recognition features so that each part, they don't have the whole features of the face. What is your second question?
Who needs to do this? Is it the federated learning client who has to do this, or we have to have some experts to do it?
I think it should be both. It's the requirements from the clients, especially their legal departments. If they want to provide service, financial service or other service to outside institutions, then their legal compliance department will decide if we want to show our intersection ID to other parties. Yeah.
Okay. Great. Yeah.
Thanks.
Thank you so much. Yeah.
You're welcome.
Right. Yeah. Thank you so much. Yes, I think that clears everything. We would like to thank Fang Jing for that very impressive, very comprehensive talk. Thank you, Fang Jing. And with that, we are coming to close. On behalf of ITU and ZTE Corporation, we would like to thank all our speakers today. Very exciting and very excellent set of domain experts who are here. Thank you for coming and taking the time to talk to our audience. And thanks to ZTE for the collaboration and coordination. Don't forget, there is a 30 minutes interaction session on AI for Good Neural Networks where you can talk to these speakers and have further discussion and clarifications if you like. Don't miss that. And there will be another event on December 8th on the same series, which paving the way towards 100% autonomy. Don't miss that as well. So with that, thank you so much for all of you to listen to us. And we would like to close now. Thank you very much.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
you.